Okay. There are two different equations that we are talking about. And the first one we did yesterday, the y is equal to mx plus b. And with the y is equal to mx plus b, the m is your slope, and your b represented your y-intercept. You could get that off of your equation. So if they give you your slope, if they give you your y-intercept, then you can come up with your equation, and they're always going to ask for you to write it in standard form. So we'll run into that equation down here in 4 and 5. The other one we haven't talked about is, this one is called your point slope. And your point slope is if they give you a point and if they give you a slope. And that's where we're going to run into on problems numbers 1, 2, and 3. If they give you a point and if they give you a slope. So on problem number 1, if they give us the point 3, 4, so that's my x1, y1. And then if they give you your slope, m is equal to 2, and they ask you to find your equation, then we're going to use that point slope equation and just basically plug into it. So y sub 1 would go in as a 4. Your m would be 2. Your x of 1 would be 3. And so your y and your x that don't have the subscript just stay y and x. And then once you go through and plug that in, it becomes nothing more than what we did yesterday. Getting it in standard form, we'd distribute the 2, subtract the 2x over, and then add the 4. So we have 2x plus y is equal to -2. And then, like we did yesterday, to get rid of the negative on our a, if we take it times a -1 through, we'd end up with 2x minus y is equal to 2. I'm going to pause. Okay, example number 2, it's pretty much the same thing. This is our x1 and our y1. Our slope is -3/4. So we plug into our y minus y sub 1 is equal to m times the quantity x minus x of 1. So it becomes y plus 1 is equal to, m is a -3/4, and then plugging -2 in for the x of 1, I'd end up with a plus 2. And then we just need to get it then in standard form. You could go through and distribute the 4 or the 3/4. I'm just going to go through and multiply each side by 4. So I have 4 times the quantity y plus 1 is equal to -3 times the quantity x plus 2. Distribute the 4, so 4y plus 4 is equal to -3x minus 6. And then finish getting it into standard form. Add the 3x over, subtract the 4, and I'd have 3x plus 4y is equal to -10. On number 3, you can make this a fraction, and treat it just like problem number 2. You could also just leave the decimal in it. If you made it as a fraction, this would be 3/5. But you can just leave it as 0.6, and so I'd have y minus 0 is equal to 0.6 times x plus 6. Either way would be fine. I'm just going to show you that the decimal works pretty much the same way. If you want to get rid of the decimal, multiply by 10, and I'd have a 10y is equal to 6 times x plus 6. So 10y is equal to 6x plus 36. If I subtract the 6x, I'd have a negative 6x plus 10y is equal to 36. And just a reminder, not only to look for that negative on your A, we need to get rid of that, but I can go through and divide this by 2 as well. So to make it relatively prime, I would divide everything by negative 2 and end up with 3x minus 5y is equal to a negative 18. Okay, questions there? Okay, on the second part, it's basically using what we did yesterday. It's using that y is equal to mx plus b, and they're going to give you the b. They're going to give you the y-intercept just as a b value. And this is just plugging in for m and b and then getting it into standard form. So if they give you the slope and your b value or y-intercept value, I'd have y is equal to 2/3 x plus 5. Getting rid of the fraction, if I multiply through by 3, I have 3y is equal to 2x plus 15. Subtracting the 2x over, negative 2x plus 3y is equal to 15. And then just getting that lead coefficient positive. So 2x minus 3y is equal to a negative 15. Same thing with problem number 5. If you have decimals, you just treat it the same way. M goes in as a 1.5, so I have 1 is equal to 1.5x. Your B is a minus 0.8. Get rid of decimals, so if I multiply through by 10, I'd have 10y is equal to 15x minus 8. Subtract the 15x over, so negative 15x plus 10y is equal to negative 8. And then taking a negative 1 through it and having 15x minus 10y is equal to 8. So on the first part, if they give you a point and the slope, then we use the point slope. On the second part, if they give you the slope and the y-intercept, use the slope-intercept form. On problem 6, it says find the equation in standard form of the line that passes through, and then they give us 2 points. We don't have a point-point form. In fact, if you really stop and consider, you always have to have the slope. That's going to be something that you're always going to have. So before we can even start on number 6 as far as plugging it into one of the equations that we have, we've got to go through and find our slope by using that the change of y over the change of x. So just designating what your points are, it doesn't matter. x2, y2. If I have 5 minus a negative 1 over 4 minus 3, I end up with, what do I end up with? You guys end up with a 6 over 1, so just 6. Okay, here's kind of the nice thing about this type of form is that you can either use your slope being 6 and the first point 4, 5, or you can use your slope being 6 and the second point 3, -1. You can choose, or if you want to use both of them, you will end up with the same answer because we're going to use our point slope form. And so I just want to go through and show you that as long as you have the right slope, if I plug in using the 0.45, we'd have y minus 5 is equal to 6 times x minus 4. So y minus 5 is equal to 6x minus 24. And I'm going to shortcut this, but you end up with 6x minus y is equal to 19. And you're going to get this exact same equation if you use 3, -1 for your point. So if I put -1 in for y sub 1, I'd have y plus 1 is equal to 6 times x minus 3. So y plus 1 is equal to 6x minus 18. And just shortcutting here, I'd have 6x minus y is equal to 19. So even though you only need to use one of the points, if you want to check your answer and use both, you should come up with the same equation. If you don't, then go back because usually your slope is wrong if you end up with two different equations.